Class 8 Science Chapter 11 Force and Pressure. In this video we'll discuss about force, a push or a pull. Forces are due to an interaction and directions of forces. First we will discuss our everyday experiences. What do you do to make a football move? What do you do to make a moving ball move faster? How does a goalkeeper stop a ball? A hockey player changes the direction of the moving ball with the flick of the stick. Now, what is the meaning of this flick? In Hindi, this is called jhatka, or in English, we can say this is a sudden, quick movement. How do fielders stop a ball hit by a batsman? In all these situations, the ball is either made to move faster or slower, or its direction of motion is changed. We often say that a force has been applied on a ball when it is kicked, pushed, thrown or flicked. Now question arises, what is a force? You can see these diagrams. A goalkeeper saving a goal, a hockey player flicking a ball, a fielder stopping a ball. In all these situations, force has been applied. Now we will discuss what is force. Force, a push or a pull. Actions like picking, opening, shutting, kicking, hitting, lifting, flicking, pushing, pulling are often used to describe certain tasks. Okay, now we will discuss one activity and we will identify actions as a push or pull. These are some description of the situation, and in this column some actions are showing, and these actions can be grouped as a push or pull. Now let us see one by one. Moving a book placed on a table. Okay, that is, book can be moved by pushing, pulling or lifting, and these actions can be grouped as push and pull. Opening or shutting a door. Actions pushing, pulling, lifting, lowering, and these actions again grouped as push and pull. Drawing a bucket of water from a well. Actions are lowering, lifting, pulling, and again these actions can be grouped as push and pull. A football player taking a penalty kick. In this, actions are lifting, kicking, hitting, and these actions can be grouped as push, not pull. Okay. A cricket ball hit by a batsman. Actions are hitting, lifting, flicking, and these actions are again grouped as push, no pull. Moving a loaded cart. Actions may be pulling or pushing, and definitely these are grouped as push and pull. Opening a drawer. Okay, to open a drawer we have to pull it. That's why action is pulling, and definitely this is grouped as a pull. Okay. Each of the actions can be grouped as a pull or a push or both. We can conclude that to move an object, it has to be pushed or pulled. In science, a push or a pull on an object is called a force. Clear? This line defines the force in science. Force is a push or a pull. Some more example. Magnet attracts a piece of iron towards it. This attraction is also a pull. Repulsion between similar poles of two magnets is a push. In 7th class we have discussed that is same pole, south, south, repel each other, north, north, repel each other, and this repulsion is also called as a push, or push is a force. Now question arises, when does a force come into play? Forces are due to an interaction. Now just again watch some situations. In this diagram, a man standing behind a stationary car. Okay, will the car move due to his presence? Definitely no. The man has to push the car to make it move, and when a man pushes, the car may begin. Okay, to move in the direction of the applied force. Some more situation. Again, you are familiar with this type of activity and this type of activity. In this diagram, who is pushing whom? We can say both the girls appear to push each other. And in this diagram, who is pulling whom? The pair of girls are trying to pull each other. The girls in the two situations shown here are applying force on each other. Now again, this diagram, the cow and the man appear to pull each other. It means they are applying force on each other. Okay, then we can conclude at least two objects must interact for a force to come into play. Thus, an interaction of one object with another object results in a force between the two objects. That is, interaction should be there, okay, between the two objects which result in the force. Now, directions of forces. Again, see this diagram. Two friends pushing a heavy load. It may be a box, okay, and these two friends are pushing in the same direction, okay, and it is easier to move it. Why it is easy? Can you explain? We can say forces applied on an object in the same direction add to one another, okay, and in this diagram, again two friends pushing a heavy load in opposite direction. This friend is in this direction and this is in this direction. If the two forces act in the opposite directions on an object, the net force acting on it is the difference between the two forces. Okay. Now again, see, this is one most familiar game, a game of tug of war, rassakasi. What happens in this? In this game, two teams pull at a rope in opposite directions. Members of both the teams try to pull the rope in their direction. This is one team. You can see this is one team and this is our second team, okay, and this is the midpoint. This team pulling in this side and this is in this side, okay. Now who is the winner? The team that pulls harder, that applies a larger force, finally wins the game. And if opposite forces are equal, what happens? The rope may not move if the two teams pull at it with equal force. Okay. We can conclude from these activities. A force may be larger or smaller than the other or equal to each other. The force is expressed by its magnitude with the direction in which a force acts. If the direction or the magnitude of the applied force changes, its effect is also changes. It means that the net force on an object is zero if the two forces acting on it in opposite directions are equal. In general, more than one force may be acting on an object. However, the effect on the object is due to the net force acting on it. Okay, student, thank you. Subscribe my channel to get the new videos of this chapter, and in the new video we'll discuss what are the effects of forces. Okay.